Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to talk about the introduction to two types of moments. First, we will talk about the moments about the origin, and then we will move on to the idea of moments about the mean. And the concept or the idea of moments comes from expanding the idea of expected value, which you have already seen in the previous video. Now, depending on whether x, our random variable here, is discrete or continuous, then the definition about rth moment about the origin is defined as such, and for this one is for discrete case where you have a summation process right here, and this one is for continuous case where you have to deal with the integration process basically. So what is the earth moment? Okay, so when you have the earth moment, you are talking about having our random variable here x, and it has x to the power of r right here. And so when you want to find what's the expected value of that, we're just going to plug in this term right next to our fx. Okay, and the mathematical symbol for that, for earth moment about the origin, is represented by this one here. We have mu at the right here, and at the bottom we have like how do we call this, prime, mu prime r. Yeah, so r here is representing what moment exactly it defines. For example, is it the first moment or the second moment? Okay, so when r is 0, you're talking about these specific special cases of 0 moment about the origin. And if r is 1, this is also a special case, so we have the first moment about the origin. Okay, so these are special cases related to the earth moment about the origin. And this one right here, let me just explain a little bit about this, like how this comes about. Yeah, let me do this. Okay, so when r is 0, what does it mean really? So it means we have that, you can see when r is 0, you're talking about this one here, the 0 moment about the origin is this one. And according to the definition, this is going to be e x, this is 0, and we know anything that has exponent 0 is going to be equal to 1. Okay, so when it is equal to 1, this becomes a constant, so expected value of a constant is just 1. So this is a special result when r is 0. Next, if we move on to this one right here, when r is 1, so you're talking about the first moment about the origin, first moment. So we have e x and 1. So this one becomes e x, and this actually is mu. So we know this as mu. So expected value of x, it is known as mu. And if you want to be more specific, you can consider that because it comes from random variable x, then we can label it as mu x. So you know, make it more specific, because later on it might be there are cases where you have x and y random variable together, so you may want to be specific as for mu x and mu y, for example. Yeah, okay, so these are special cases when r is 0 and when r is 1. These are the results. Okay, now let's move on to the next definition, which is let's talk about the earth moment about the mean. So here we talk about the earth moment about the mean, and if you look at the definition given here or the formula given below, you can see that when you talk about the rth moment about the mean, you are considering this random variable x, and you have to like subtract that with the mean. So this is the mean of that random variable, and again on the top part here we have r that is to represent what moment exactly you're talking about. Is the rth moment, okay? And similar with the idea that you have seen in finding expected value of something, what you need to do is we're going to take this whole thing here and we're going to plug in right next to fx. Okay, so this is what's going on. So this is the rth moment about the mean. So when you talk about the mean, so you talk about rth moment about the mean, we're going to have a subtraction process here between our random variable x and its mean, and at the top part here is r to represent a specific rth moment. And again, you want to find the expected value of something. We're just going to put that something here right next to fx. Now I hope that becomes pretty clear with you, how we can do this, you know. And similar to what I have said so many times before, if you are dealing with a discrete case, then of course the formula that you're going to apply has something to do with the summation process. And if you're dealing with the continuous case, of course you will be looking at solving some sort of integral. And notice that when you talk about the rth moment about the origin, about the mean, the symbol or notation used for this is just mu r. So there is no prime at the top part right here. So compare this formula or this mathematical symbol with what you see right here. So this one is for moment, rth moment about the origin. The difference is we have mu prime r, and this is the rth moment about the mean, where you have just mu r, and those symbols differentiate these two different concepts. Okay. Well, I hope you can see the similarity sort of between the definition of rth moment about the origin and rth moment about the mean. So basically when you talk about the rth moment about the origin, okay, so when you look at the definition of rth moment about the origin, the definition is as such: mu prime r. Okay, so here we might have e. Actually what we have right here is ex minus 0, because we're talking about the origin is usually depicted by 0.0 r. Okay, so when you have that, anything that minus 0 is going to be that itself. Okay, so x minus 0 is going to be simplified as x, so xr. So that's what's going on right here. That's why we have e, then x to the power of r. On the other hand, when you talk about the rth moment about the mean, so this is the definition, you're going to have something, your random variable will be subtracted with the value of its mean. So this is mu, so r, and there is no way to simplify that further, so that's why the definition is given as such. So you can see that there's actually similarity in the sort of similarity in the definition of rth moment about the origin. So here we have to minus 0, but somehow with the process we can simplify that to x to the power of r. Okay, and this one is the definition for rth moment about the mean. So you have to subtract the mean from that random variable. Okay, now let's consider some special cases when r is 0, when r is 1, and when r is 2, and we're going to demonstrate that this is a 0 moment about the mean. Okay, about the mean, and we're going to demonstrate that the result is equal to 1. Now this one is the first moment, also about the mean, and the result is 0. And this is just for your information. For example, in particular, when you have R is 2, this becomes the definition of variance of x. Okay, so that is variance of x. All right, let's start off with the first one. Okay, so we have right here is R is 0. Okay, so when R is 0, what we have is mu 0 is e x minus mu to the power of 0. So this is the definition. And then we can have, you know, that anything with exponent 0 is going to be equal to 1. Okay, and so expected value of a constant 1 is going to be equal to 1. So there you go. R is equal to 0. The result here is 1. Now when R is 1, what we have is mu 1 is equal to, according to what we've seen, the formula requires us to write down x minus mu to the power of 1. And that can be simplified as x minus mu. And we can separate this process. We can get ex minus e mu. And we know from the previous slide, ex is actually an average of a random variable x. So average is denoted as mu. So this is mu of x. Or we can say mu because right now we only have one random variable, so we don't need to really specify the subscript right down at the bottom there. And mu here is also a constant, so when you have expected value of a constant, it's going to be the constant itself. So we got mu, so the answer is going to be equal to 0. And of course, when you have R is equal to 2, from the definition, we have mu 2, and this is the idea where you have x minus mu and you square it, and this is what it means by the definition of variance. So when R is equal to 2, this formula here represents the formula in order to find the variance of x. And we will look at that later on. Okay, so don't worry about it right now. What we have is this is the formula for finding variance of x, or another way we say another word of it is vx. Okay, so this is the usual symbol that we use to denote the variance of a random variable. All right. So for this one right here, what we're going to do is if x is a random variable with mean mu and variance sigma square, we're going to prove that this result is true. Okay, so what we're going to start off is we have a random variable x with mean mu. So basically it means the expected value of x is going to be equal to mu, and then variance of x has to be equal to sigma squared. Okay, so what we have here, so this one is variance of x basically, and we're going to prove that the left hand side here is going to be equal to this one. This is the value on the right hand side. Right, so we're going to start off with we know that in this slide right here, when R is 2, you get this formula, and this formula is the formula to find variance of x. So this is our starting point. All right, so we're going to have variance of x is actually equal to mu 2, and this is actually, according to the formula, it is just x minus mu, you square it. Okay, and we have no other choice but to expand what we have here in the bracket. So we have e x squared minus 2 mu x plus mu squared. And what we can do next is we can separate these three items right here. So what we have is e x squared minus e 2 mu x plus e mu squared. And you can see that this can be further simplified if you take out the constant out. Okay, so that's what we're going to do next. We're going to settle the constant first. So here we've got 2 mu is the constant, 2 and mu, so we can take it out, 2 mu. This one is also a constant, mu squared is a constant, so the result here is going to be equal to mu squared. Okay, now we can further simplify that with this one. We have ex squared minus 2 mu. Ex is, like I said, is actually equals to mu, so we have times mu plus mu squared. Yeah, and then what we have next is we can simplify that to be ex squared, so negative 2 mu squared plus mu squared. Okay, negative 2 mu squared plus mu squared, the result is going to be negative mu, and you square it, negative mu squared. Yeah, okay, so this one can be simplified, this one, this. Okay, you can simplify that to negative mu squared. Okay, so this one becomes mu times mu is mu squared, so here we got negative 2 mu squared plus mu squared, the result is negative mu squared. Okay, now what is this? This is actually you can see this is the definition of second moment about the origin. This is the second moment about the origin, and we know that the notation for that is mu prime 2 minus mu squared. So we have managed to show that variance of x, which is actually denoted by this symbol, is equal to this result right here that you have obtained on the right hand side, which is similar to the one shown above. Okay, all right. Okay, I think that's all for now. We shall stop here, and we will continue with perhaps other examples related to finding the variance of x or standard deviation of x in the next video. Okay, right, thank you very much for watching, and I'll see you in the next video. Yeah.